Hello viewers, still on trigonometry, we want to show that sine square theta plus cos square theta equal to 1. So we go to the solution. So before we solve, we have to draw a right angle triangle. So we have this. Okay, this will be our theta. This is angle 90. And so we can call this C, being the longest side hypotenuse. We can call this A, and then we call this B, okay? Let's use small letters, so let's call this C, let's call this A, and let's call this B. Okay, so we are going to be using this to prove that sine square theta plus cos square theta equal to 1. And so we know that from Pythagoras theorem, from Pythagoras theorem, that the hypotenuse, the longest side, is the square of the longest side is equal to the summation of the square of A and B. So we are going to have this to be that A square plus B square equal to C square. Okay, so this is Pythagoras theorem. And so having established this, we can call this equation 1. So from our equation 1, we can say from divide both sides of equation 1 by C square. So when we do that, we are going to have A square divided by C square plus B square, this one divided by C square, equal to C square divided by C square. Okay, since we've done that, we can cancel out this because they are the same, so that will give us 1 over 1. So we take our new equation is going to be A square over A square over C square, as for this first one, plus B square over C square equal to 1 divided by 1 will give us 1. And so we can call this equation, okay, that's the second equation, we can call it equation 2. And so we can do this, that since this is square, this is square, this is square, this is square, so we can do it this way: A all over C all squared is the same thing, plus the square here is raised power 2, so you can do it this way: all squared equal to 1. So since we've been able to establish this, we can now say, okay, if we call this, let's call this equation 3. Okay, from here we can now say, but sine theta is opposite, sine is opposite over hypotenuse, which is equal to, opposite is A, so we have A over, hypotenuse is C, so we have A over C, that is our sine theta. And so we look at cos theta now. So cos theta is k, which is, okay, let me do this way. Sine theta is so, which is equal to opposite over hypotenuse, which is our opposite because this angle is facing A. So we have A over hypotenuse is C. This is the hypotenuse being the longest side. So cos theta, we are looking at cos theta now. So cos theta is car. So which is A represents adjacent all over H is hypotenuse. So our adjacent is B all over B all over, and our hypotenuse is C. So if you look at this, we've been able to establish that sine theta is A over C, which is what we have here, and then that cos theta is B over C, which is what we have here. So we can substitute the value of sine theta into this equation 3. We can now bring this sine theta and put it here since it is A over C, and now bring this cos theta and put it here since it is B over C. So if we have to do that, we are going to be having sine theta is A over C. So we have, in place of A over C, we now put sine theta. But it is raised to power 2, so we say all squared plus B over C is cos theta. So we have cos theta. And because it's raised to power 2, we have all squared equal to 1. This is our equation 4. And then we can sine theta all squared is the same thing as sine square theta plus cos theta all squared is the same thing as cos square theta, and this is equal to 1. So we can call this equation 5. And so looking at this, we've been able to show that sine square theta plus cos square theta equal to 1 using this right angle triangle. Thank you.